Service-Stack Jobs is a framework for durable, fast, and observable long-running tasks in your application powered by SQLite. It comes with a new admin UI giving you live progress updates, logging output, and more so you can manage the background jobs powering your system. Service-Stack Jobs is a great complement to those building on top of SQLite for cost-effective systems that don't need to scale beyond a single host. It follows the same pattern we introduced with Service-Stack Commands feature to isolate your reusable logic, and expands on that concept to provide durability, scheduled tasks for reoccurring jobs at configured intervals, and a real-time admin UI. These features are powered by a SQLite database, which makes Service-Stack Jobs highly portable since it has no additional infrastructure dependencies. To walk through how Service-Stack Jobs works, first we will need to create a Service-Stack project, which we can create from our start page at servicestack.net/start, or by using the servicestack.net x tool and the command x new blazor-view myapp. We will use the Blazor View template as our basis to get started quickly using Service-Stack Jobs. Opening your new solution, we now have a Blazor and Vue.js powered application styled with Tailwind. The Blazor View and other Service-Stack templates like Razor and Vue Spa come with Service-Stack Jobs pre-configured with an example used to send emails in a background job. If you have an existing application based on our templates, you can also use the command xmixjobs to get a jumpstart using Service-Stack Jobs. In your new solution, you will have a file in your app host project called configure.backgroundjobs.cs, which configures the background jobs feature plugin and the related dependencies. This file also includes a jobs hosted service class, which is a .NET background service to start our Service-Stack Jobs and check for updates every 3 seconds by default. If you wanted to change the interval of how often SQLite is checked for new jobs, this is where you would control that. Before we run our application, we have to initialize the database, and we can do this by navigating to the app host project, opening the package.json, and running the migrate npm task. The Blazor View template and others come with a built-in example of using Service-Stack Jobs for optional email functionality. This can be enabled quite easily by uncommenting the registration of the email sender and removal of the identity no-op email sender from the program.cs file, and providing some SMTP config in your app settings.json. For your SMTP config settings, you will need an email provider or service like Amazon SES. After your app settings are updated and you have started your application, we can have an email fired off by registering a new user. This is because these templates come with ASP.NET Identity for authentication already configured, and we're able to get an account confirmation email automatically sent. Once we've registered a new user, we can use the built-in admin user to view details of the send email command job in the built-in admin UI. Navigating to /admin-UI, logging in with the default example admin user and clicking background jobs, we can see the send email command job that ran and look at the input, output, and related logs to that specific job. Now that we have our application set up, let's have a look at an initial example to see how the rest of the system works. Here we have a custom async command with result called checkURLs command. It declares a checkURLs input class. Async command with result can also be used if your command has an output. It has a single run async method, which is an override of the base class that we implement as our isolated piece of logic, which in this case is a command that calls a list of URLs to see if it is up and running. So we have a checkURLs for our input, checkURLs command as our piece of logic, and the checkURLs result for our output. To run this command, we use the iBackgroundJobs singleton that is registered in our application's IOC thanks to the configure.backgroundjobs.cs file. Calling jobs.enqueue command, we specify the check URLs command type, passing in the check URLs instance as input. This will immediately run a command as a .NET task since we haven't specified a named worker. So uniquely named workers will run jobs serially per worker, whereas not specifying a name will run all jobs immediately and concurrently. We can specify a worker name by using the second argument in the enqueue command function, which is a background jobs option. Let's have a better look at how this works by running this command. Here we have created a Service API to enqueue our check URLs command using an injected background jobs without specifying a named worker. Running our application and navigating to the API Explorer, we can see this service on the left-hand menu. Clicking on the service, we can call it with a new line delimited list of URLs, and we get a response instantly with the background job reference information. Submitting this form several times, we still get a response straight away with the generated IDs, since these jobs are being enqueued and responding to our service. If we want to see our jobs running, we can use the built-in admin UI by signing in with the example admin account at the top right and clicking on background jobs. Here we are greeted with the background jobs dashboard, giving us a quick overview of recent jobs and some simple statistics, like showing us how many jobs have been run, failed, cancelled, etc. At the top, we have a tabs list, including dashboard, queue, history, and scheduled tasks. Clicking on the History tab, we can see the check URLs command that have run as we called our service, or we can filter them by completed or failed subtabs below. Clicking on one of these jobs will show us the details of the job, including the input and output type details for this specific run, along with some logs. If we navigate back to the Queue tab and use a different browser tab to fire off some more check URL commands, we will see this queue light up with our in-progress jobs showing us live updates. We can even click on those in-progress jobs and see the background job log information flow through as the job is being processed. Firing off these jobs, you can tell that they're all running concurrently, and this is because we haven't specified a named worker when we are calling the enqueue command method. If we have a command that we only want to run serially, we can give it a fixed worker name, for example, name of check URL command. Applying this change and hitting the service that enqueues this command multiple times, we can view the background jobs admin UI and see that we have several jobs waiting to run while only one is progressing through. Another option available when enqueuing jobs is the callback property. This enables us to specify another command name that becomes an extension of the original job. For example, if we have a check URLs report command inheriting from async command, we specify the input type the same as the output or result type from the check URLs command, which in this case is check URLs result. Callbacks always take the output of the original commands as input, and they run as a single job together. If you want more control, you could enqueue the check URLs report command from within the check URLs command itself by using a primary constructor injecting the background jobs and using it the same way we do from our Service API example. You can also access the background job instance from within the running job to access the background job options that were passed to the enqueue command. A good use case for accessing the job like this is the use of the ReplyTo option. This enables you to provide a way to handle functions like webhooks or similar functionality through the base job option. We have an example of this in our AI server open source application that is powered by Service Jobs. We use the ReplyTo as a standard option to enqueuing commands that will call back to the provided URLs. How you use the ReplyTo is up to your specific application requirements, so you could leverage this for emails, SMS, and other types of notifications that match your own conventions. There are loads of other flexible options baked into ServerStack Jobs, like depends on for queuing up longer running workflows that depend on each other, running commands in the context of a specific user, tagging, BatchId commands, and more. We will be diving into deeper examples in the future, and I'll link in the description some of the applications we've used ServerStack Jobs in for different use cases to show real-world examples of how this library can be leveraged to build performance SQLite applications. Well, that's it for this video. If you have any questions or feedback on ServerStack Jobs, let us know in the comments below, or you can join us on our community Discord or GitHub discussions. ServerStack is free for open source projects and individuals, so anyone is welcomed. And as always, thanks for watching.